problem number 8 gives us two functions. Y equals cosh x is equal to e to the x plus e to the negative x over 2, and sinh x, which is equal to e to the x minus e to the negative x over 2. It says that these are called basic hyperbolic trigonometric functions, and it asks us to sketch the rough graphs of these two functions. So these are universally understood functions, and you can see them here. It's just a parabola and this curvy wave looking thing, where on the parabola you have the vertex at 0, 1, and you have the middle of the curve at the origin. And you have there again, we wrote it out, cosh x and sinh x. And then what it does, it says graph the equation y squared minus x squared minus y squared is equal to 1, which is shown below. Sorry, the graph of x squared minus y squared is shown below right there. This is called the unit hyperbola. For any value a, show that the point xy is equal to cosh of a and sinh of a is on the unit hyperbola. Hint, verify that cosh of x squared minus sinh of x squared is equal to 1. So basically putting cosh of x and sinh of x in for x and y respectively. So all we have to do is, excuse me, set cosh of x, there it is, minus sinh of x squared equal to 1. So there's cosh of x and sinh of x. Ignore that 2, sorry, up front. And then we FOIL it out, and what you end up getting, that 2 is supposed to go down there. You get 2 plus e to the 2x plus e to the negative 2x minus, all in parentheses, 2 plus e to the 2x minus e to the negative 2x over 4. And then the e to the 2x's and e to the negative 2x's cancel out. And then what you're left with is 2 plus 2 over 4, which is indeed equal to 1. So now we're going to go to part C, which gives us y is equal to a cosh of x minus h over a plus c. And for appropriate constants a, h, and c, the constant h depends on how the coordinate system is imposed. It's going to tell us how to do that in a bit. And that equation is for a cable right here, suspended from two 100-foot towers that are 400 feet apart, and impose a coordinate system so that the picture is symmetric about the y-axis and the roadway coincides with the x-axis. So we're basically right where this arrow for D is, that's going to be the y-axis, this roadway is going to be the x-axis, which means these points, I'll show you what I drew out, are going to be, it's going to look something like this. So you have 100 over there, you have these points, negative 200 and 0, 200 and 0, and then the top of the towers, 200 and 100, and then negative 200 and 100, with some distance that we're going to try to find. So the first thing that we start off doing is understanding that y is equal to a cosh of x minus h plus c, where a is 500 and h is 0. That was just given to us. And then we y of x, we set a equal to 500, and then we set a equal to 500 there. And then y of 200, we got from the height, or from the distance between the two towers. Y is just going to be in between these two guys, or so it's just going to be 400 divided by 2. So y of 200 is just going to be 100. So y of 200 is equal to 500 cosh times 200 over 500, putting 200 in for x, plus some variable or some constant c. And what that leaves us with is y of 200 is equal to 500 cosh 2 over 5, because 200 divided by 500 simplifies by 2 over 5. And then you subtract 500 cosh of 2 over 5 from both sides. What you end up with is y of 200 minus 500 cosh of 2 over 5. We already talked about how y of 200 is just 100. And so we get 100 minus 5 cosh 2 over 5. Now we know that cosh of x is e to the x plus e to the negative x over 2. So everywhere there's an x here, we just put in 2 over 5. What you get is e to the 2 over 5 plus e to the negative 2 over 5, or 0.4, all over 2. you just plug it into your calculator, and what you end up getting is 100 minus 500 times e to the 1.0811, which gets you to 100 minus 540.55, which gets you negative 440.55 for C. And then what you do is, what you need to find is the minimum distance, D, and D is going to be at where x equals 0. So we just plug in 0 for x, and we get 500 times cosh of 0 over 500, which is cosh of 0, plus C, which we just found is negative 440.55, and we multiply, or we sub in the 0 over 500 again for x everywhere where x is on this formula, and what that leaves you with is e to the 0, which is just 1, plus e to the negative 0, which is just 1, so you get 1 plus 1 over 2, which simplifies to 1. So that cancels out to 1. You end up with 500 times 1 minus C, or plus C, which is negative 440.55, to get 59.45, which is the minimum distance D can be. That's it, thanks.